Hey.
Yeah, I can't resist. I'm curious.
Okay, so two very easy questions to see if you trust your common sense, okay?
I probably don't have any. But
So I have 3 pictures of my water bottle here, and I painted the water blue with food coloring just to make it easier to see the water.
Okay.
I want to see if you can tell me what's the difference between these 3 water bottles.
Right.
Actually,
since-
1,
yeah.
2, and 3. Let's form like this. Yeah.
Okay. Yeah. So since water, and this is air.
Yeah, air, and that's a ping pong ball.
Oh yeah, the ping pong ball, right?
Yeah.
Okay. Like most people probably say, the gravitational field is pointing this way, and this way.
Okay, so which one is in the correct orientation, would you say?
Oh.
Because obviously the bottles are in different orientations.
Yeah. Yes. Right. So the floor would be
There we go.
here, here, and here.
You got it, yeah. So why would you say that? Obviously because of the water, right?
Yeah.
The water is showing you the direction of the ground.
Yeah, because my understanding of physics is that the liquid is more dense than the air.
There you go, yeah. It's literally that simple. You got it.
So is there another
So,
trick?
no, so that's it. You got the first question right. So I have one more.
Oh, yeah, okay.
Yeah, so one more. This one's even easier, but
Okay, did anyone fail that one?
believe it or not, people have. I know, it's pretty easy though.
Alright.
So another thing about water, when it's contained and at rest, not only does it always go to the bottom and push the air to the top, it always finds its level as well. So if you had to define level, how would you define it?
Oh. That's a great question.
Yeah, what's your
right?
definition of level?
Yeah, definition of level.
So like one of these-
Gravitational equipotential is the most succinct way I can describe it.
Okay, you could look this up, but the one-word definition is
Okay.
a horizontal straight line. So you could have a straight line, but if it's in an angle or a slope, it's not level.
Right.
So it has to be a horizontal straight line, and that's what level means. No deviation in elevation from any given point.
Right.
You know, in water, you know, when it's contained and at rest, it always finds its level.
Yeah, I would argue, just for the
Sure.
shits and giggles, that gravitational equipotential is slightly more general because there's the assumption that gravity is uniform. But if you have, say, a much more esoteric region of space-time where the gravitational field is non-uniform,
Okay.
then the water would actually take the shape of whatever that warped space-time is. Yeah.
That's what I'm saying. When it's contained and at rest here on Earth.
Of course, yeah.
It's
In,
contained here.
under normal circumstances.
Yeah, here on Earth, contained and at rest.
Yeah.
Surface is always level, always horizontal.
Exactly.
So again, if you understand what level means and when water is contained and at rest, which one of these two represents water level?
Again, under the assumption.
Under the assumption
of,
here on Earth,
Yeah.
contained and at rest.
This one.
It's the obvious one, right?
Yeah.
So the real reason I'm doing this is because over 95% of the population, including myself and maybe you, have been tricked to believing this is what level means, even though we know it's this
Seriously?
one. Yeah. You want to know how we were tricked?
Yeah.
Do you believe the Earth is a ball in outer space?
Yes.
Yeah, so NASA, they claim to have satellites orbiting the Earth, right? So they need to know the radius of orbit. So they need to know the radius of the Earth if they're supposedly going around it. So they do tell us the radius of the Earth is 3,959 miles, which means there has to be curvature every mile, and every mile it has to increase because they're claiming it's a curve, not a slope. So in the first mile, it's an 8-inch drop, second mile, 32 inches, and by the third mile, it should be 6 feet of curvature.
Right. So this is actually consistent with my explanation of gravitational equipotential.
Yeah.
Since gravity is, radially symmetric.
Exactly.
Then, locally, right, it's flat.
Did you know that Neil deGrasse Tyson says that the Earth is not a perfect sphere? They call that would contradict that definition of level, though.
So here's the thing, right?
It's an oblate spheroid.
It is an oblate.
But that would contradict your definition of equal potential.
No, but all we have
Sure.
in our understanding of reality are models, right?
Models?
Yeah.
What about physics?
Yeah, physics is nothing but models.
I would
right?
say...
No.
Okay,
So here's the thing, right?
Sure.
I'm a scientist.
Sure.
Technically, all models are incorrect.
Okay.
It's just some are useful.
Okay, sure.
Some are very good at predicting. Right?
Yeah, when we're talking about...
So when we're
model of
talking
the Earth,
about
yeah.
the spheres,
Sure.
just for sheer convenience, we assume an approximation of a sphere, right? There is no perfect circle in existence. there's no such thing as a perfect sphere,
Sure.
right? This is not a quantum particle. It is made up of a very large order of magnitude of particles that coalesce under a mutual gravitational attraction.
Right. So, okay, just real quick, because I know we're kind of getting into these theories of gravity, for example, but okay, so if we went to a giant body of water like a lake, like let's say we went to a lake that was 10 miles across, right? They're telling us that in 10 miles there is a 66-foot drop. So if you're standing on one end of that lake, at the end of that lake, they're telling you that the end of that lake is going to be 66 feet lower than you are at the beginning.
Maybe approximately.
But physically, water doesn't have the ability to hump. Because water doesn't have a shape or...
No, but this is what I was saying. Your assumption is correct under the assumption, right, that the gravitational field is uniform, right? So here, it is approximately uniform, right?
Okay.
So you can, if you could imagine a gravitational field line, right, that points downwards, right?
I could imagine that.
Yeah. Between here and here, those lines
would parallel.
Yeah, but they're approximately parallel.
Yeah,
right?
the longer distance.
Longer distance, right?
Yeah.
You start to see that. Oh no, you have a concentration of mass that is spherically symmetric.
Right. I don't know if you knew this, but I'm glad you brought up the verticals. I don't know if you knew this, but in engineering, all verticals, all plumb lines are considered parallel regardless of the distance. So that would contradict.
No. Yeah,
you could look this up in engineering class.
I know. The thing is, plumbing systems do not span planets.
No, they span hundreds of miles though for bridges. So there's blueprints that show no curvature.
Do you know what a geodesic is?
Yeah, I know what a geodesic is.
Okay.
That's not what's happening.
Plumbing. Okay, let's just cut through it.
Sure.
You're a proponent of that the Earth is flat?
No. So the flat Earth is a psyop, and I'm gonna tell you what the difference is between level and flat. So you could have a flat wall, right?
So this is semantics.
It's not semantics; it's reality. So reality is showing.
No. Words have meaning.
Meaning,
have
exactly.
definition.
Yeah,
so,
exactly.
To the common person, level and flat mean the same thing.
No, it doesn't. Because you could have a flat wall and it's not level. You could have a flat slope. And it's not level.
I understand.
So there's a huge difference. And here's here's another difference though. Level has to do with orientation. So the Earth does have orientation, and in order for something to have orientation, it needs to be moving. So the Earth is pushing up against you. It's not you being pulled towards the Earth.
I'm familiar with the concept of a normal force.
Yeah.
This is why we don't.
So I was going to ask you, what is gravity in your opinion? What is gravity?
Gravitation is the curvature of the space-time background which all fields inhabit.
Would you say gravity is a force, or is it not?
Technically, I would say it is not a force.
It's not a force.
Technically, yeah. Most students are taught that it is a force, right?
That's Newton's theory. Yeah.
Technically speaking, right, it is not a force. For example, when you're in freefall, there is no force, right? So then
you want to know why there's no force in freefall?
You don't have to tell me.
Why? You tell me then. You tell me why. How do you know that there's no force in freefall?
There's no net forces that is changing your...
Okay, somebody told you that, but how did you verify that there's no force in freefall? Because I could tell you, but...
I haven't run the experiments, but there is... if there was an inconsistency, it would have shown up.
You want me to show you why there's no force in freefall and why Einstein had to come up with this whole theory of...
Sure.
Okay, so the real reason is, you know what buoyancy is, right?
Yes.
So what is buoyancy?
Buoyancy is... it emerges from the fact that you have substances of different densities.
Yeah.
Right? And so, you will have objects with greater mass and therefore greater weight sink towards the bottom, and then there will be a.
So buoyancy, it's something that's less dense than the medium that surrounds it.
Yeah.
And that medium is basically pushing that less dense object in the direction of the force. So for example, here, I accelerated this bottle, and I recreated buoyancy by obviously showing the air bubble getting pushed in the direction of acceleration. What direction did I accelerate, down or up?
So this would be because they're more massive material is going here. And because of inertia, I would say this is being accelerated. Yeah, this is a good question, by the way.
Yeah.
It's being accelerated this way.
You got it. Because again, the air pressure, the water pressure.
This is high school physics.
Yeah, it is. It's actually in elementary physics, I would say. So in free fall, here, let me show you what happens in free fall. There is no buoyancy, basically. So let me see, this one's it. Yeah. So in this one, here, let me turn it this way. As soon as I release the bottle, so again, the air bubble shows you the direction that is being accelerated. So the air bubble, when you're holding it, air bubbles go up because they're being pushed up. But as soon as I release it, that force vanishes. So the air bubble doesn't travel up anymore. It just stays where it's at. Look at that. As soon as I release it, it just stays where it's at.
What claims?
So that proves that there's no force in free fall.
Sure.
And it's the Earth pushing up. So gravity is a push, not a pull. So the Earth is a level plane pushing up against you. So that's what buoyancy is. The helium balloon goes up because it's being pushed by the air, and the air is being pushed by the ground. So the Earth is moving through space. I wouldn't say space.
No, that's wrong. Sorry, that's incorrect.
Well, that's what physics shows. That's what I'm saying.
No.
So what is buoyancy? How does gravity pull something down and push air up?
It has to do with density. Density is not.
But density is not a force, though.
I never said it was.
Force causes motion. So what's causing?
Density is mass divided by volume.
But it's not a force, is my point. Density alone is not a force, and you need a force to cause motion. That's my point. So what would be the force pulling a heavier object to the ground and an air bubble up? How can a force work in two directions at once? That wouldn't make any sense.
No, I see what you're.
And that's why there's no force going down. That's why Einstein had to come up with his explanation of the bending and warping of space-time. That's just a theory, by the way. It's not reality.
Every description is a theory, right? No.
Not if we could demonstrate it and prove it.
No. Okay, you have to not confuse the word theory with hypothesis, right?
Well,
in science, a theory is simply a testable description of reality. A hypothesis is a guess that could be wrong, could be incorrect.
Okay,
the layman, right, conflates the two,
right?
And they are totally different, distinct concepts.
So what about what do you
think?
think?
Say just a theory. What people actually mean is just a hypothesis.
What do you think?
Relativity is not a hypothesis. It is a theory that has been tested time and again. Right?
So what do you think about the scientific theory? No, not scientific. Scientific method. What do you think about the scientific method?
I have yet to come across a more reliable methodology for acquiring knowledge from the environment.
I would say the scientific method is a method that's used to prove things. For example,
I would say you cannot prove things.
I could prove that we could build cars.
You can demonstrate it.
Well, we could get in a car and drive it. It physically exists.
Yeah, but if you want to be technical, proofs can only be done in the realm of mathematics. Okay, you can demonstrate things in reality. In science, you can only disprove a theory. That general relativity is a legitimate, is the description of space-time.
Right. But I can't prove that steel is stronger than wood.
Yes.
Would you deny that or no? Well, obviously, you have to accept that steel is stronger. That could physically.
You can demonstrate.
I could physically, scientifically prove that steel is stronger than wood.
Two different types of things, right? One is
stronger than the other.
No, I'm talking about the demonstration that
I can demonstrate to you that steel is stronger than wood.
Let me finish. The demonstration that steel is stronger than wood, right? Proving that is different than applying the word proof to a scientific theory. You cannot prove any scientific theory.
Yeah, because it's a theory. I agree. Yeah.
No. But because it is you can.
So you disregard their scientific facts. You disregard that. You don't believe that there's scientific facts.
I do. Scientific facts and scientific theory are two different things.
Okay, explain to me what a scientific fact is then.
A scientific fact is just simply an observation.
Give me an example.
Okay, that the strength of the gravitational force, on average, right, on the surface of this planet is 9.81 meters per second squared.
Okay, I would say that's an observation.
That is a fact.
I would say that's not a fact.
What is the difference between an observation and a fact?
An observation is something that you just simply observe. For example, we can observe this this core, and I can.
Yeah, but you can repeatedly.
No, I can just by looking at it, I can tell you it's 20 feet tall.
There is.
But that's not fact. The fact will be physically measuring it to see how tall it is. So
I gave you an example of a measurable fact.
No, when you're observing something fall, you believe that the object goes towards the ground, first of all, right? That it's being accelerated towards the ground.
Yes.
I'm telling you that physics shows that that's not what's happening because you need force to cause motion. So if you're claiming that this
you don't need force to cause motion.
Can you show me an example of something moving that doesn't require a force?
Space-time.
Well, that's a theory. I need something in reality. Like something here on Earth. Can you show me something that's moving that doesn't require a force here on Earth?
No.
No, because again, motion requires a force. So if you're claiming this is motionless...
That's not the reason I can't show you. The reason is I cannot manipulate space-time.
Well, that's because you're going into the bigger scale of things.
Exactly. Yeah.
You're going into imaginary physics.
It's not imaginary.
Because it cannot be demonstrated here on Earth.
Yeah, but it doesn't... Just because something cannot be demonstrated in front of you doesn't mean it's real. It's not real. Right? Well, I can't observe galaxies. That doesn't mean that other galaxies don't exist.
Do you believe that flying reindeer are possible then? Because you can disprove that, I guess, or whatever?
No.
Or you haven't experienced
That's an excellent question. Now we're getting into epistemology and ontology and the very concept of belief. So, technically, I have no choice but to be agnostic. I can hypothesize that flying reindeer exist, but it's on me, it's my responsibility to demonstrate that they exist, right?
Exactly,
but I cannot technically say they do not exist.
I could. Because I trust my common sense, and a reindeer is more denser than the air, and the air will never be able to sustain a reindeer. It would be impossible.
You cannot state that. You cannot say, conclusively. You have to demonstrate. Okay.
That defies physics. Anything that defies physics, in my opinion, I don't accept.
Physics, the way so there's two types of physics. There's physics, there's the laws of physics that we humans have constructed as a theory, as a description of the actual reality. Right?
Yeah.
But these are two distinct things. There's how reality actually operates, and then there is through the scientific method,
our interpretation.
The utilization of mathematics and consistent repeated observations, right, to construct a theory or discover a law, right, that is consistent under certain assumptions and approximations, right?
Okay.
For example, relativity, even Einstein admitted this, is incorrect at the quantum scale. It is a classical theory.
Okay, sure.
By construction,
it
is wrong. Everything is wrong, but it doesn't
everything
matter.
about the heliocentric model is wrong. Yeah, because it's all a theory.
Every description that you have, that I have, that every human has, is wrong.
Okay.
Right? But what's the difference between a good theory and a shit theory that doesn't describe or predict any aspect of reality? The difference is in its ability to make predictions that are consistent with observation. This is why you need theory and experiment in science.
Sure, I understand theories obviously develop technologies because we have
obviously the scientific method works.
Yes.
Obviously none of this would exist.
Exactly, I accept that. The thing
this is no different.
No, when you have theories that are not backed by practical things that contradict reality or unknown, that's where I'm like, it's bullshit. But theoretical scientific theories that are backed by the practical, then that's possible because this actually works. But when your theories defy physics, that's when I'm like, what if I told you that theoretically I could walk through walls? Would you accept that, like it's possible, or
I accept that's possible?
You accept that matter can go through matter. You know that two pieces of matter cannot occupy the same space at the same time. That's a fact.
Fermions cannot.
Could you accept? I mean, that would defy that fact.
You're not even letting me explain.
No, but go for it.
I think it's possible. I think the probability of observing that would require a 10 to a very large number times the lifetime of the universe. And you can actually probably do a back of the envelope calculation because, yes, you are correct that courtesy of the uncertainty principle, you cannot have two-way fermionic wave functions overlap, but you can have quantum tunneling.
Okay, what's it? Quantum tunneling?
Quantum tunneling,
What is that? Can you explain to me? Because quantum tunneling,
It is it's a basic feature of modern physics, which is quantum mechanics. It is what enables
quantum
us.
tunneling.
Are you not familiar with quantum mechanics?
Quantum mechanics I've heard of, but
If you've heard of quantum mechanics, or if you've looked into it more than 5 minutes, then quantum tunneling you would learn about. I actually just
does it have to do? It sounds like teleporting or something. I don't know. What is it?
Yeah. So tunneling. So it's very simply, in quantum theory, you can describe matter and particles using a complex wave.
Okay.
Right. So there's a wave function and there's an equation called the Schrödinger equation. Okay. If you solve that for a particular system and for a particular energy, then you can study how the complex wave interferes or interacts with different dielectric material.
Okay.
I would have to explain what a dielectric
sure.
is.
Okay, I just wanted to like the surface of it.
The surface level is, for example, light. Light is massless, right? So you can imagine how light passes through transparent materials.
Right.
That light at the quantum scale is made up of particles. Right. How do those particles get through to the other side?
Right.
Well, it's an interaction of that wave with the matter. Right?
Yeah, I would say light is not like obviously solid. It's not it's not like
it doesn't. Yeah, it doesn't have mass, right?
Yeah, it doesn't have mass.
I'm just
exactly.
using that as an example.
And that's why I think it goes through mass because it's not mass. Because you can have two mass occupied the same
but
space.
there's still an electromagnetic interaction.
Sure.
Okay. It turns out that for massive particles, you can also have wave-like properties.
Sure.
This is another essential property, right, of matter, as described by quantum theory.
Sure.
Every experiment we've done appears to confirm this fact, because you can measure. So we have experimental physics.
Yeah. And that's why, again, a simple fact. Again, you could deny this, and again, when water's contained and at rest here on Earth, every lake on Earth, when it's at rest, the surface is always a perfectly horizontal plane.
It's not perfectly horizontal.
Well, the closest we could get to water's the number one tool.
As you zoom out, there's curvature.
Okay, I would say that's just imaginary.
How is it imaginary?
Because it doesn't exist in reality. In 10 miles, there should be
Where did you get this data?
This data is coming from NASA, the radius of the Earth.
No.
This is just the curvature rate based on the radius.
Mind if I take a photo?
Yeah, I could take a photo of that one and this one. This one's a much easier one to understand. You're familiar with the Pythagorean theorem? A squared plus B squared equals C squared, right?
Yes.
I did this one myself based on the radius of the Earth, and the numbers of the curvature are still the same. So it's two different formulas using the same radius, giving us the same numbers. So these numbers, the curvature drop, people can't run away from these curvature drops. The drop that they're claiming should be there in every lake on Earth. But the fact is, water doesn't have the physical ability to bend on the surface. It's just impossible. It defies physics in all levels. The fact
water
that
doesn't have the physical ability
to bend when it's contained in at rest. When you have a body of water contained in at rest, the surface will never bend to form a hump or a ball, for that matter. That just defies physics. And again, I go with what reality shows me. I don't go with what people tell me.
Okay. So, if it defies your physics,
it's
that's one thing.
Sure. You could say my physics.
Yeah. We can talk about physics as an attempt to describe reality, and then we can talk about reality. The reality is it does bend.
Okay. So how did you come to that conclusion then? How did you come to the conclusion that it does bend? What told you that? What in reality told you, or did somebody tell you?
Obviously, I do not have access to spacecraft, and I cannot. My background is in quantum physics. There is a level of trust that is required.
Okay. So it's faith-based.
Well, we can talk about faith as well, right? For example, I have faith that everything I observe is not just in my head, right? There's a philosophy that posits that everything is fake except me.
Like a dream, basically.
Yeah, exactly. This is called solipsism.
Yeah, I've heard of that.
Yeah, I have faith that I do not exist in a solipsistic reality. Yeah. Right? I choose my axioms based off of convenience. Right? It is inconvenient for me to operate under the assumption that
I would say
exist
that's
in a-
philosophical. You're getting into philosophy.
You cannot escape philosophy. when it
Would you
comes
say
to the
philosophy and
scientific
physics are the same then in your mind?
I
would say they're separate.
method. I would say that there is a philosophy of physics, and there is
Yes.
a philosophy of the
That
scientific
comes after
method.
understanding physics, then we do get to philosophical because we don't know what this place actually is.
That's
So-
right, and the best we can do is come up with consistent, coherent, predictable models, which are called theories.
Yeah, I don't push a Earth model. I know the flat Earth disk is a model that they're pushing, and that's the way they're
But
ridiculing it.
apparently every
I
other
don't-
celestial body is actually round except Earth.
So the lights in the sky, I don't know if you knew, nobody's actually been outside of the Earth because you familiar with the second law of thermodynamics?
Yes.
What's the second law of thermodynamics?
Yeah, it's that in any closed system, the total entropy increases.
Exactly. So how can you have a space next to Earth's pressure with no?
Because it's not a closed system.
Well, that's what I'm saying. You need a closed system to maintain pressure next to an open system, like space.
No,
You can't have two opposing
you-
pressure systems next to each other without a solid barrier. That's my point. Entropy would ensue. In other words, we wouldn't have air pressure here.
The presence of mass warps space-time.
So again, going back to gravity.
Yes,
Yeah.
and that is what causes all this matter to coalesce
But-
down, with heavier particles getting pushed downward more.
So what if
there's
I
a
was-
stronger gravitational pull?
So the fact is, the downwards vector that people claim gravity is actually an upwards vector. The vector is up, not down. So the Earth is pushing up against you, not pulling you down.
no.
That's the
The
reality.
reason why, first of all, it's relative to your coordinate system. So
Sure.
if I say the ground is my origin, right? The reason I'm not accelerating is because there are competing forces. There is the normal force.
What
right,
is
which
this normal force? Yeah.
Maybe take introductory physics.
No, what is the normal force in your?
The normal force is a resistance force due to the electromagnetic repulsion between the electrons on the atoms at the bottom of the soles of my feet and all the atoms that constitute the top layer of the ground.
Okay.
Okay?
You would say that's the normal force, right?
It's a force that prohibits my acceleration. So there's a concept called inertia, right? Newton's first.
Yeah. So you know force F equals ma. You know what that means, right?
Well, it's F net equals ma, right?
That
The
means-
sum of the forces.
So a force is something that's moving. So something has to be moving. That's what a force is.
No. The mass is moving.
Yeah, exactly.
force
The
is
mass
not
of the
moving.
Earth is moving. That's why the normal force, it's funny how they do tell you the normal
No.
force is actually the real force. And the only force that exists.
They don't say that, and that is not true.
No, because
The reason I'm not accelerating is because the normal force is equivalent in magnitude to the gravitational force, but opposite in direction.
right. No, yeah, I'm familiar with Einstein's.
Basic vectors. So the net force is...
So you're saying you have two vectors right now.
Exactly.
So what's moving up is my point, and what's moving down.
Nothing is moving.
So nothing's moving.
A force, no. Yeah, a force is related to the gradient of a potential. Okay, there's a gravitational
So
potential.
what's causing this to go down right now is my point, I guess, in your
the
opinion.
gravitational force?
So it's so right now it's still, and as I release it, it's accelerating from 0 to whatever it is.
yes.
So it's an
yes. There's a gravitational force there.
So you claim, so you believe there's an acceleration down. So
Yes.
you need a force to have acceleration.
Yes, we call gravity a force.
But it's not a force, is what you're saying.
Yeah, but it's not. The reason it's not a force has nothing to do with what you're explaining. And even if it did, you have to provide. You could publish this, by the way.
Yeah.
Okay, provide an explanation for the upward force that you
It's
call
the
gravity.
Earth pushing up against us.
Okay.
So it's part of the creation, basically.
Part of the creation.
This is an
Well,
intelligent.
what about on the other side of the planet, right? What do you mean? So that you're saying that
Yeah, on a globe, it wouldn't make any sense because that means the Earth will have to be expanding.
exactly?
Exactly,
yeah.
but the Earth is not a globe; it's a level plane that just has one direction.
So you're saying you
Up
are a
is up for
proponent of-
everybody.
So you believe the Earth is flat.
It's level because it's moving. In order for something to have orientation, which is level, it needs to be moving. You need motion. So again, flat Earth is a psyop because over 99% of flat Earthers claim the Earth is motionless, and they're all bullshit. So flat Earthers are dumb as fuck. No offense to anyone.
What is the source of energy that propels the Earth?
everybody
yeah,
asks that.
naturally,
Yeah.
naturally.
Well, since we can't go outside of the Earth to observe what's causing.
We've been. All right, I think I don't think we can progress.
All right, man. Thanks for the chat.
Hey,
appreciate it.
I appreciate the opportunity to get people to think, you know?
Yeah.
So,
you want to take my channel? Maybe you could see some of the... I only go to universities, by the way. You can check them out. Other conversations I have.
sure.
Yeah, there
sure.
you go, man. Appreciate the chat, man.
I appreciate the challenge. And this has been an insightful conversation.
Oh, yeah, definitely. Yeah, I really enjoyed it, man. I really enjoyed this conversation. Appreciate it.
Good luck.
Yeah, if you have any questions, my email's on my videos and my description. You can check it out.
Yeah. Unfortunately, you're not the first, and you probably won't be the last. But,
Probably not, no, for sure, I'm not going to be the last. That's for sure.
Yeah. I only wish I had more time, right?
No, same here. Same here.
Because when it comes to teaching, right, and education,
Sure.
the best way to learn is actually to teach.
Yeah. Right. In a way, I guess. Yeah.
I would say so. That's my opinion.
Sure.
Right? Because you very quickly start to realize, like, very quickly, like any and all gaps, no matter how small in your understanding, just thinking and discussing ideas can inspire you to maybe consider the fact that either you don't have a complete understanding or some part of your understanding is incorrect. So regardless of whether it's you or me, in this particular instance, as an example, I think it's important to be open to the possibility that your understanding could be flawed.
Yeah.
Some aspects of what I was describing might not be technically correct, right? So that's the question, is how do we arrive at a consensus where we have a formal mathematical structure? I don't know how to not use mathematics.
Well,
to
math
describe
is just a
reality.
language. I don't know if you knew that. So it's just like English.
Yeah, but it is internally consistent, and there are rules, there's algebra.
It's just arithmetic. Math is just arithmetic in a language. Basic.
Right. But good luck trying to turning all of this that exists could not be done without mathematics.
Yeah, math, again, a language.
So
sure, in a way, it's a useful tool when it's used practically. But when you're using this tool to prove something imaginary that you can't use, that's where it goes abstract to me. It's abstract. Math has to be attached to something
math
real.
Math is abstraction.
No, it's an abstract, but it has to be attached to something real if we want to take that math serious. But if that math is not attached to something real, then it's just theoretical.
Just theoretical, right. There's been so many, the power of theoretical physics has allowed us to predict and confirm all sorts of things that are real.
Yeah, even create cars, from theoretical physics. Exactly. But that was attached, those theories were attached to something real already that existed.
Obviously, what we can observe.
But theories that contradict our known understanding of physics, and you try to push those as real using math, that's where...
Give me an example.
So again, the second law of thermodynamics, you claiming that there's an outer space next to Earth's pressure without a solid barrier, that defies physics, that contradicts physics. So
it does not contradict reality as we observe it.
Well, you show me a gas pressure.
We have an atmosphere.
Show me gas pressure here without a barrier. You can't. The air will always expand to fill in the void.
We've gone to space. This is where we cannot proceed.
And I respect your beliefs. Just like that.
And I do not. I unfortunately cannot respect yours.
Well, that's fine. I don't have beliefs. I either know something or I don't. And I know that the globe Earth is just imaginary.
Your plan to advance science is to do all the experiments yourself. If you cannot see it with your own eyes, you cannot trust any other human being that says.
Yeah, if another human being is making a claim to me about reality, but they can't reproduce it, or where did they get it from then? They can't show me, where did you come up with that idea?
You're going to be very limited in your ability to advance science. You understand this, right? Some engineering projects are so big that they cannot be done without large groups of people, without NASA, right?
I agree with that.
So if you choose to restrict yourself and say, I cannot believe these other groups of people that have done these collaborative efforts, you will be very limited in what you can actually prove.
Yeah, but if this group of people are actually building a bridge physically, I will go and help, and I'll be involved in understanding.
So you're going to join NASA, and you're going to help, or SpaceX, and you're going to assist with building rockets so you can see it with your own eyes.
I don't even need to go that high. Again, water shows me that it's a physical impossibility to hump like Jello. It doesn't have...
Well, I am highly dubious of the validity of those numbers and of the.
You should double check them yourself using the Pythagorean theorem. Very easy.
No,
the numbers are there.
Wait, sorry. I don't know if I took a photo.
Yeah, take a picture of this one.
Maybe I already did.
Yeah, take a picture of this one. And again, this is based on the radius they're telling us. And again, they could say the radius is double that. They could say the radius is 8,000. It doesn't matter. There still has to be curvature.
And then there's another one. Right?
Yeah, take a picture of this one. This is the exact curvature rate. And this is the Pythagorean theorem. But yeah, I mean, I really appreciate the chat.
Yeah, I will gladly take some time out of my very limited free time.
Trust me.
To check these claims and look at these numbers.
Yeah,
and,
appreciate it, man.
I think it's also, like I've said before, important to be open to the possibility that those numbers, that you are wrong.
Okay, sure.
Or that the mathematics that you're applying may not be appropriate. Okay. That's another thing in theoretical physics.
Fair enough.
Right?
Fair enough.
Some types of math are appropriate and some are not, depending on the physical system.
Sure.
So
these are two different formulas giving us the same numbers based on the same radius.
Right. The formulas you're using for a model that you have of level 1, right?
Well, these are based on the globe Earth model. 3959 is the radius of the imaginary globe they're telling us. So that's where I'm getting those curvature numbers from, which fail when we put them into practice and reality. They're not there. Water doesn't show that.
What do you think would be the purpose of? So do you think every scientist and engineer who we won't even like waste 10 seconds at your station? Do you think they are deliberately being obtuse and hiding the truth, or do you think they are just stupid, uneducated, or have some inability to conceive of this, high school, elementary school math? What do you think is?
So at a certain level, there is people straight up lying. So I would say
a certain level.
To a certain level. These have to be coming from somewhere, obviously. Somebody that's lying. Because people did not come to these in the natural world, these numbers. Obviously.
What will they gain to benefit?
Well, I would say it comes back to control. So it's a cheap shot on our common sense when we're very young to trust authority over our own common sense. Because when you grow up,
how do you teach without trust? This is trust. This is the concept of authority. You want us to return to the Stone Age?
So if I was to teach something to my child, for example, I don't want them to believe me. I want them to understand what I'm teaching.
Right.
That's the difference. So when they teach us about the globe, they don't teach us how to understand how they came up with this. They just tell us. We're just being told. We're not being taught. People are not understanding my point.
Because life is short.
Sure. But like you said, this is very elementary level.
We will never be able to travel the cosmos.
Sure.
If we force children to reinvent the wheel, right? That's going to take a good fraction of their youth, right?
I mean, they don't need to recreate the wheel. They just need to understand how it works. And
that's what we teach. These are observations. We have a consistent model. Yeah, question everything, right?
Yeah. The inside of the 6 main proofs that contradict the globe Earth claim. Give them a read again, when you have some free time. Euclidean plane geometry.
Yeah, but again, over a long enough distance, the material will bend.
I mean, even
materials are not these. It's not a video game.
No, what I'm saying is, though, they account for all that from the level. There's the blueprints. They account for all these bends and all that from the level.
Just as there's no such thing as a perfect circle, there's no such thing as perfectly flat.
Water, when it's container, is the closest thing.
There
might be little
water
waves.
Is made up of water with molecules.
Yeah, but what I'm saying is that water doesn't have a shape or form. It takes the shape of the
container,
and the surface always equalizes because it doesn't have the shape.
Under the gravitational field, which is not uniform. It is not uniform.
I would say that that's just a
field
theory.
Is not uniform. We've observed it with high precision.
Just observing something appear to go down?
Different parts of the planet. Okay. The planet is not a perfect sphere, right? Just the fact that you have different elevations. When you're drawing the is a perfect perfect circle.
Yeah.
This is a fiction. Well, you can tell right here, right?
Sure.
If the Earth was perfectly flat, we wouldn't have a building, right? I wouldn't exist. We'd all be flat.
I don't know where you're getting that from. Like.
I'm getting the fact from my observation.
So if the Earth was, first of all, it's not flat, it's level.
Exactly.
It's level. It's a huge difference. Flat has nothing to do with orientation. So a lot of flat earthers do claim the Earth is motionless, but it's not.
Okay, we're starting to go in circles here.
Sure.
So,
All right, man. Thanks again, man. Appreciate the chat.
I appreciate the challenge.
Yeah. All right.